Hello friends, my name is Pooja Arora and I'm giving you a video lecture series on the topic matrices. And in our last video lecture, we have discussed about determinant. Determinant is a single value for a particular matrix, and we have already discussed that how we can find the determinants of a 2 by 2 matrix or a 3 by 3 matrix. Okay, and then after that I have cleared an example to find an area of triangle or to prove that the points are collinear with the help of determinant. Okay, so the next step in this chapter is to find the minors and the cofactor. Very firstly, I want to make it clear that it's a sequential process to study all these topics. So if you are not very sure about determinant, firstly check those videos. After that, you can understand how to find a minor or how to find a cofactor. So we are starting with the minors. We are going to learn in this topic that how we can find a minor. So basically to find a determinant or to find a minor, it's a quite similar process. You only have to understand that we find the minors of a particular element. Just like we are finding a determinant value for the complete matrix, here we are finding minors of particular elements. So if I have a 3 by 3 matrix, that is a square matrix, and that is the first condition to find the determinant or a minor, that the matrix should be a square matrix. So if it is a 3 by 3 matrix, I can get the minor of each and every element. As in the starting video, I have already mentioned that we can give a name to a matrix, that is matrix A. So we denote the matrix by capital A and we denote the elements by small a. So I will write A11. What is A11? It is 2. That we already know, right? And now we are going to find out minor of this particular element. That means I will denote this M11. M11 means minor of the element at first row and first column. So how we can find the minor? The simple procedure we are going to repeat, that I am going to find the minor of this element, first row, first column. So I will hide the first row and I will hide the first column, that I will eliminate the row and the column of that particular element. So I will eliminate this row, I will eliminate this column. What will be the remaining elements? These. So I will find the determinant of these elements, -1, 4 and -2. So as you know how to find the determinant of a 2 by 2 matrix, in this way you can find this by multiplying these two elements. 5 into -2, I will get -10. With a subtraction sign, I will multiply these two elements. 4 into -1, I will get a -4. So what I get here, I will get -10 plus 4. So 10 minus 4, it will give me a -6. So the minor of my first element M11 will be -6. So I hope you got the point and the concept to find the minor. In the same way, we can find minor of each and every element. What is the procedure? That eliminate the row and the column of that particular element and find the determinant of the remaining matrix. Just like now I am going to find the minor of this element, that is M12, first row, second column. This I am going to find the minor of this element. So what will I do? I will just eliminate this row, I will just eliminate this column. So if I eliminate this row and this column, what will I get? I will get -4, 6, -1 and -2. Okay, here I get some numbers with the negative sign. So calculate it very carefully. If the calculation is wrong, means if a single multiplication you got it wrong, your complete answer will be wrong, because it's a step-by-step process. So do every step very carefully. Actually, in mathematics, doing a fast work is not important. Doing the correct work is more important. So when you are doing it in examination, just be careful and do it correctly. Okay, so let me just find out the minor. I hope you all know the process now. Multiplying the main diagonal element minus multiplying the second diagonal element. So it will give me a -6. It will give me a 8 and plus 6. it will give me a 14. So this is my minor of the second element M12. In the same way, you can find the minor of all the elements. If you are practiced enough, you can find the minor directly by looking at the matrix, just like I'm eliminating this row, this column, multiplying these two elements. So it will give me -8 minus 30, so it will be minus 38. But that is completely okay for you if you are doing it first time in a BCA first year syllabus. That if you can't get it directly, just write it like this, and after that you will get a correct answer. Okay, so in the same way, I will find all the minors here. I am done with my first row, so I am moving to the second row, M21, and I am eliminating my second row now and the first column. So what will I get? I will get 1, 3 as I eliminate this row, and 4 and minus 2. 1, 3, 4 and minus 2. So I am getting minus 2, minus 12. So it will give me a minus 14. M22, second row, second column, what the element is? Element is 5, and if I eliminate the second row and the second column, what will I get? I will get minus 4 and minus 18. So it will give me minus 22. Okay, you can do it with me and check the calculation of your own. If I find the calculation of M23, I will just eliminate my second row and the third column, and you will get 8 minus 6. It was 1 initially, so it is 8 minus 6, it will be 2. And now we have only the third row, so just move it to the third row, M31. So I am working on this element now, so I will eliminate this row and I will eliminate this column. The remaining elements will be these 4. So I have to find out the determinant, so I am multiplying these two elements, that is minus 1 and minus 15. So it will be minus 16. Okay, and M32. The second element in the third row, this one. So I will eliminate this column, second column, and I will eliminate the third row, this one. So if I eliminate these two row and columns, what will I get? I will get 2, 3, minus 4 and minus 1. And if I will write it, okay, for your concern, I will write it here, 2, 3, minus 4 and minus 1. So what will I get? Minus 2 minus minus 12. So it will become a plus 12 and minus 2. So it will give me a 10. So these. Okay, so we have done till M32, that means we have find the minor of this element. In the same way, you can find the minor of that element, that is M33. And M33 means I will eliminate my third row and I will eliminate my third column and find the determinant of the remaining element, that is 2, 1, minus 4 and 5. And to find the determinant, I will multiply 2 and 5, that is 10, and with a negative sign I will write minus 4. So it will give me a 14. So this is a way, a procedure to find the minors. I think the concept is clear till now, that how we can find the minor. Very simple procedure. If you want to find a minor of maybe this element or this element, just eliminate the row, eliminate the column and find the determinant of the remaining matrix. Okay, so in this way you will get the minor of that particular element. Okay, so I think minors are clear now. Just for the sake of completion, or maybe to clear it, understand clearly, I'm just making a matrix of the minor, right? I have a matrix A which I have given in my question. I'm making a matrix M which I find all the minors. I'm making matrix with them. That is M11 I got is minus 6. M12 I got is 14. So according to the position, I'm just arranging the minors, all the minors in a matrix format. So what is M13? That is minus 38. Now the second row, 2, 1, minus 14, 2 2 that is minus 22, 2 3 that is 2, 3 1 that is minus 16, 3 2 that is 10, and 3 3 that is again 14. Okay, so this is the matrix of minors which we got. All the minors which we found, which we calculated, we just make a matrix of that. Okay, so how to find the minors is clear now. So we are moving to the next subtopic, that is how to find a cofactor. Minor and cofactor are quietly related. So what is the way to find the cofactor? Let me just remove the calculation part here, and I will just tell you how you can find the cofactor. This was my M12. Okay, so what is the way to find the cofactor? Cij is equal to minus 1 raised to power I plus j Mij. Okay, this is the formula which you have seen in your textbooks or maybe in your notebooks, that this is a formula to find the cofactor. This looks complicated, but this is the simplest formula ever. What you have to do, you just have to change the sign of the minor. Maybe change the sign plus to minus, maybe plus to plus, but we are deciding the sign only. We will not change the value of the minor. That means in the cofactor we will have the same value 16, but maybe it will be positive, it will be negative. So we are going to decide the signature, the sign, the plus or minus. So for that we have this formula. What we are going to do, we are just multiplying the minor value with minus 1 and minus 1 raised to power I plus j. So what is ij here? I think you already know with my all previous videos that ij is the position number. So if I talk about this, I will say this is M11. So 1 and 1 is the position number, the row number and the column number. So I denote my row number and j denote my column number. Row number and j means column number. So if I want to say, just like say I want to find the cofactor of the first element, that is C11, I want to find the cofactor of this element. So what will I do? I will just follow the formula minus 1 raised to power I plus j. Now what is I here and what is j here? Both are equal to 1, first row, first column. So I will write it here 1 plus 1, and then Mij. What is M11? M11 is 6, as you already know. So sorry, minus 6. So I'm writing it like this. Okay, now here is the point, that when you make a power to minus 1, okay, so 1 is a number, you multiply it how many times? It will be 1 only, so the value will not change. But again, sign will change. So how it will be changed? If this power is in even numbers, just like 1 plus 1 is 2. So when we square the minus 1, so minus 1 into minus 1, it will become a plus 1. So that's a trick, that if you are making power of minus 1, if the sum of the power, total power is an even number, it will become positive. If it is odd number, then it will not change. So 1 plus 1 is 2. So minus 1 become plus 1, because minus 1 square is equal to plus 1, and multiplying it minus 6 is give me the minus 6 only. So what is C11? That is minus 6 only. Okay, so no change. Now let's say I'm going to check what is C12. That means the cofactor of this element, first row, second column. I am going to find out the cofactor. What is the formula says? Minus 1 raised to power I plus j. What is I here? 1. What is j here? 2. So I am writing in 1 plus 2. So what is 1 plus 2? It will be 3. And Mij. What is Mij? It is plus 14. Okay. So 1 plus 2 is 3. Okay, so minus 1 raised to power 3 is equal to minus 1. If you are still not sure how to do the power of minus 1, you can do it like minus 1 into minus 1. So when I have the power 2 plus minus into minus plus, so I will get a plus 1. But when I have a power of 3, here minus 1 into minus 1 into minus 1, so minus into minus plus, plus into minus, again give me a minus. So it will give me a negative sign and the 14. So C12 is minus 14. As you can see, M12 is positive 14, but C12 is negative 14. Minor was positive, but the cofactor is negative. Okay, so this is a way to find the cofactor of the given matrix. You can find the cofactor of every element, C12, C13, C23, all the elements. Just like if I want to find the cofactor of this, that is C22, second row, second column. So I will write here minus 1 raised to power 2 plus 2 M22. So 2 plus 2 is 4 and it's an even number, so it will become plus 1. So plus 1 multiplied with minus 22, it will be unchanged, that is minus 22. Okay, so in the same way you can find all the cofactors. Okay, I hope you get the formula, you get the procedure to find all the cofactors with the formula. But then when you are solving a question, a lengthy question, if you don't have time to put on the formula and to find each and every cofactor, I will give you a short trick in which you can find the cofactor by the minors within seconds. Now what's that? So the second method to find the cofactor matrix is, this is your minor matrix, minus 14, minus 22, 2, minus 16, 10 and 14. This is your minor matrix. Okay, and I have to find out the cofactor one. How to find the cofactor? Only you have to choose these 4 elements. The elements which make the diamond shape in the matrix. These 4 elements which make the diamond shape in the matrix, I will choose these 4 elements. I will change those sign, plus to minus, minus to plus. Other than all the elements are unchanged. I'm not going to change the sign of 6, that is always be minus 6. I'm not going to change the sign of this. I'm not going to change the sign of this. I'm going to change the sign of 14, minus 14, 10 and 2, and then it will become a cofactor matrix. Just like I'm writing it here, that minus 6, minus 14, minus 38, that is unchanged. This minus 14 will become positive 14, minus 22 will be unchanged, 2 will become minus 2, minus 16 will be unchanged, 10 will become minus 10 and 14 will be unchanged. So this will be my cofactor matrix. Okay, so what I did, I just changed the sign of these 4 elements just to understand why these 4 elements. In the formula only, I have already told you that when you do the power of minus 1 I plus j, if it is even number, then the value doesn't change. If it is odd number, the sign will be changed. So here we have one first row and second column. So here I plus j equal to 3. Here we have second row first column, so I plus j equal to 3. Here we have second row third column, so I plus j equal to 5. Here we have third row second column, so I plus j is again 5. So I selected all those location or positions which give me I plus j with a odd number, and I just change the sign, and my minor will become the cofactor now. So this is my matrix of cofactor. So in this video we have covered 2 steps. The first step, how to find the minor. The second step, how to find a cofactor. And for cofactor, I have told you the formula method and I have told you the short trick, both of them. Okay, so you can find either way. If you have enough time, if you want to use the formula, you can find the cofactor one by one, and if you don't have time, if you are in hurry, if you are in rush, you can find the cofactor directly. Now the very small topic here, one more thing which you have to calculate, that is called adjoint. How to find the adjoint of a matrix, and many times the question in your paper comes that find the adjoint of a particular matrix. For that you have to follow some steps. So what is a adjoint, or how we can find the adjoint? That is very simple, that if you transpose your cofactor matrix, it will give you an adjoint matrix. Okay, so from minor we will calculate cofactor, and from cofactor we can calculate the adjoint matrix. What is the procedure said? That you have to transpose the matrix, and I think you all know how to transpose a matrix. I have already discussed in my operation on matrix video. If you are not very sure how to transpose a matrix, you can go back and see those videos. Okay, so to transpose a matrix, what we will do, we will just change rows into columns and columns into rows, and then it will be transposed. So if I am going to transpose this matrix, what will I get? I am just selecting my first row and making it my first column, that is -6, -14 and -38. So this first row is my first column now, and the second row will say 14, -22 and -2. Now third row will become my third column, -10 and 14. Okay, done. So this is called the adjoint. So if I ask you my initial matrix and find the adjoint of that particular matrix, this is the procedure you have to follow. Very firstly, you have to find the minors of all the elements. Then from those minors you have to find the cofactor. From those cofactor you have to find the adjoint by transposing it. So this is a method to find the cofactor, to adjoint and minors of a particular matrix. I think that's all for today, and in the next video we are going to find the inverse of a matrix. So the question is how to find the inverse, then you have to follow the complete procedure. Okay, in today's video we have discussed till adjoint. Thank you so much. If you have any question which you can't get, you can write it in the comment section. I will solve it for you. Thank you.